till now we have discussed about linear motion, then equations of motion. Then another type of motion that is known as circular motion. This is comes under curvilinear motion and circular motion. Whenever we said that a body is said to be in circular motion, so the body is said to be in circular motion if it moves in such a way that its distance from a fixed point always remains constant. Its distance from a fixed point throughout the motion, the distance from the fixed point should be constant. That means, what is the fixed point? The fixed point is the center of the circle. What is the fixed distance? The fixed distance is the radius of the circle. And the path covered by the body is the circumference of the circle. So this is the circular motion. Then uniform circular motion. When a particle moves in a circle with constant speed throughout the motion, if the speed is the same, then we said that the body is in uniform circular motion. What are the examples? There are various examples of circular motion. Motion of the planets around the sun, motion of the electron around the nucleus is the examples of circular motion. Then what are the various terms related to circular motion? What are the various terms related to circular motion? In every type of motion, whether it may be linear motion, it may be circular motion, rotational motion, every motion. Motion means there is a displacement, velocity, acceleration and time. These four terms there must be. So in circular motion, the displacement is known as the angular displacement. The displacement is known as the angular displacement. So what is angular displacement? Now, it is the angle turned by the radius vector. See this figure. This is the circular motion. This is the center, O is the center, OA is the radius, and the body is moving in this path. And when the body is moving from A to B, let the body is moving from A to A dash. A to A dash. What is the displacement it occur? Let the displacement is del S. Okay. So angular displacement means what is the angle turned by the radius vector? This is the radius. This is OA dash is also the radius. This radius moving from A to A dash covering how many angle? That is known as the angle turned by the radius vector is known as the angular displacement. Its symbol is theta. Its symbol is theta. It is represented by del. Del means small. Del theta. So del theta is equal to del S by R. Okay. So it is the angular. What is angular displacement? What is angular displacement? It is the angle turned by the radius vector. And what is the relation between angular displacement and linear displacement? This is angular displacement. This is linear displacement. The relation is this. If we divide R with linear term, we find the angular term. Or if we multiply radius with angular term, we can find linear term. So del theta is equal to del S by R, or del S is equal to del theta into R. Then angular velocity. Next one is angular velocity. Like linear velocity, what is velocity? Displacement by time. In angular velocity also, it is the angular displacement by time, or it is the rate of change of angular displacement. It is the rate of change of angular displacement is known as angular velocity. So it is represented by omega. The symbol is omega. This is not W, this is omega. So it is represented by omega, and its unit is radian per second. And what is the unit of angular displacement? The unit of angular displacement is radian. Its unit is radian. It is a vector quantity. Its unit is radian. And since the unit of angular displacement is radian, and angular velocity is equal to angular displacement by time, so its unit is radian per second, or it is defined as the angle described by the particle as omega is equal to del theta by del t, that is equal to del s by r by del t. So del s r into del t, so del s by del t is equal to v, so v by r. So the relation between angular velocity and linear velocity, v is the linear velocity. If we divide radius with linear term, we can find angular term. In the previously we have also discussed that. So omega is equal to v by r, or v is equal to r omega. V is equal to r omega. Then the next concept is angular acceleration. The next concept is angular acceleration. What is linear acceleration? We have already discussed about. Like linear acceleration is equal to, it is the rate of change of velocity. Like that, angular acceleration is defined as also the rate of change of angular velocity. The rate of change of angular velocity. So it is represented by alpha. It is represented by alpha. Always remember alpha. And alpha is equal to omega by t. Alpha is equal to omega by t. And then what is the relation between angular acceleration and linear acceleration? What is the relation between angular acceleration and linear acceleration? If we put in place of omega, omega means angular velocity. What is the, we can write omega as linear velocity is equal to v by r. Previously we have discussed that omega is equal to v by r. Putting that value, omega is equal to v by r. So v by r divided by t. So rearranging this, v by rt. So v by t, this v by t, velocity by time, linear velocity by time, that is equal to acceleration, linear acceleration. So linear acceleration divided by r. So alpha, angular acceleration, is equal to linear acceleration divided by radius. That means in this case also, if we divide radius with linear term, we can find angular term. Then cross multiplying this, we can find a linear acceleration is equal to radius into angular acceleration. Radius into angular acceleration. Now question is, what is its SI unit? What is the SI unit? What is the SI unit of angular acceleration? What is the SI unit of angular velocity? The SI unit of angular velocity is radian per second. Putting the value of radian per second in this case, so alpha is equal to omega by t. In the unit of omega is equal to radian per second. So radian per second divided by second. So the SI unit of angular acceleration is radian per second square. The SI unit is radian per second square. So these are all information about circular motion which is in our syllabus. In this case, we have discussed about circular motion, uniform circular motion, then the various terms related to particularly angular displacement, angular velocity and angular acceleration, and what are the relations between the angular term with the linear term. Angular term with the linear term.